Number 4, it's a little bit different kind of problem. It says the manager of a sporting goods store offered bonuses to his salespeople when they sold more goods. New manager dropped the system. We took a random sample of 6 salespeople and show you here the weekly sales with and without the bonus system. Does this imply that sales dropped when the bonus system was discontinued? Now, we don't have summary statistics here. We have the actual data. So from these lists, I can figure out the means and the standard deviation. I really like this problem because on the surface, it looks like it's going to be a 2-sample problem. Here's a sample, and here's a sample, and I could go through and find X bar 1 and X bar 2 and S1 and S2 and use that to do a 2-sample problem. But when I get to the requirements, one of the requirements of a 2-sample problem is that these 2 groups need to be independent of one another, and in fact, they are not independent of one another. For example, what do you notice about salesperson number 3? That person does a great job, much better than person number 1. With and without the bonus, it doesn't matter. Person number 3 is doing a better job. Maybe we need to give these people names. Maybe this is Amy and Bella and Charlie and Daniela and so on and so forth. Well, we see that those numbers for Charlie and those numbers for Amy are not independent of one another. So what we end up with here is not a 2-sample problem, but rather a matched pairs problem, where these 2 groups match up. These 2 groups match up. And so what I'm going to do is find a 3rd column for the difference. In other words, the first one is going to be 0.1, and the next one's going to be 0.5, and the next one's going to be negative 0.1. And then on this list, I'm going to perform a t-test. So what I have is a matched pair t-test. And my null hypothesis is that the mean, the true mean of this new red list is going to be 0 versus it's not 0. We might think that, in fact, I would probably, now that I've written that, I would probably think that this would be bigger than 0. And if it's bigger than 0, that means the number in the top row would be bigger than the numbers in the bottom row. And that's probably what we might think because they're giving a bonus. So we want to see if the bonus was a good incentivizer. My requirements need to be that these 6 people need to be an SRS. I need to say since N is small, I need rough symmetry, and I'll graph that for you in just a second. And I could get 10 times 6 salespeople. So let me show you how I'll do this. In my calculator, I'm going to put these 2 lists of numbers. So in L1, I'm going to put these top numbers. And in this list, I'm going to put the second list of numbers. And then in L3, I'm going to make that the difference of these 2 lists. So I'm going to say L1 minus L2. And I get what I was starting to have right here. Now from that L3, I could do, for example, 1 var stats on L3. There's my X bar and my S. I could also make a quick histogram of L3. And I hope that this is not too out of whack, because if it is, that's going to be a problem. It might be right skewed. It's hard to tell. The data set's so small, but that's what I'm trying to do right here. I need to include something there. And I might say, it's a little skewed. This bothers me. It's not too bad. It doesn't bother me that much. But some sort of statement like that next to this would be great. So now my formula is going to be t equals x bar minus mu over s divided by the square root of n. Since it's t, I've got degrees of freedom, which are 5 in this problem. I can go stat, test. Now, if I'm showing work, here are the numbers I want to plug in. But if I'm not showing work, or if I'm using my calculator to actually do the work, I can enter the data this time instead. This is 0. My data is in L3. And we said we wanted to do the one-sided greater than test. That's this. Calculate. Chicka chicka whir whir. There is my t-test statistic. There's my p-value. It doesn't show you degrees of freedom here because they think you can just do the -1 in your head, I suppose. And so we end up here with 2.876 is t. My p-value is 0.017. And if alpha is 0.05, I'm going to reject because that number is small.